it's recording. Okay, so when you guys built that chart, so this is your parent function. So remember, every time we said it fits into like the mold of the A, X minus H, K, so like we can fit that stuff right here. If things are written in that format, we can use our transformations. And so for this graph, same values, but like we said, we know it's undefined at 0. So if I plug in -2 for the parent, I have like -1/2. If I plug in -1, I should have -1. If I plug in 1, I should have 1. And if I plug in 2, I should have +1/2. So when you plotted those points, they kind of look like, oops, this. And then if you just plot those points and you had no knowledge of what this graph looked like, that would be incredibly difficult to understand what's actually happening. But that's why we do something like the investigation to understand how the graph works. You should have some idea that this graph looks like those 2 branches, and then these are just guiding points for those 2 branches. So one branch is going like this, and another branch is going like this. Okay. Getting really close to, but not crossing either of those asymptotes in this case. We'll talk more specifically about the asymptotes later. Some of them can be crossed, some of them can't. And then we do want to identify what those are, because this function is more than just about connecting points. The asymptotes are almost more important, because that's where you know that you have the guidelines for the function. So we want to know that in this parent function, besides just having that table of points, we have this vertical asymptote at x equals 0, as well as this horizontal asymptote at y equals 0. Okay? You can even put those asymptotes, if you need to, kind of like with your chart, because you can adjust them the same way we do the transformations for the measurements of the points if you don't know where they automatically are. Okay? So when we go through here, I told you I don't like this. We can make a note if we want that in this case h is 0 and k is 0. Those are important to us about the shifting of the function, but we really don't want to think about them as a point here, because that will confuse us as far as how our asymptote is, how our asymptotes are working. We already saw from our investigation that both the x and y intercepts in the parent function were none, because that happened to be where our asymptotes are, and then our function didn't cross that line. Okay? What is the domain of the function? So this is where your restrictions come in handy, right? Your domain is all the x values you can plug in. If you understood what you were doing with restrictions before, you were telling someone the x values they cannot plug in, right? So the domain is like the opposite of that. What are all the things I can plug in? So what is the domain of this function? Just say it in words. Yeah, Stefan.
Like negative, from negative infinity to less than 0.
Okay, good. So like on one side of 0 and then on the other side of 0 also, right? So there's a couple ways you can say this. I'm okay with you guys saying, and be prepared in like future classes, they might make you be a little stricter on the notation. I'm okay if you guys just say something like x cannot equal 0, okay? Or you can say something like all reals except x equal to 0. Or if you want to write it in interval notation, okay, our intervals would say from negative infinity to 0. This is like what Stefan was saying, like everything less than 0. And then also from 0 to infinity, those two things together, those intervals basically are a way to write intervals that just skip one number. It skipped 0. Even though you see 0 in there, it doesn't have the square bracket, so I didn't include 0, okay? Or you could say like x is less than 0 or x is greater than 0. That's basically what I've said with the intervals. So a few different ways that you can write that. Okay. And then if we use that as an example, how would we write our range in this problem? Because when you look at the graph, does it go infinitely upward and infinitely downward at a certain point? Yeah. Okay. But does it skip something along the way? Yeah, there's one y value we're not hitting, right? And that's the value of 0. So we have the same issue we had with the domain, but we're talking about y values instead of x values here, okay? So either you can talk about y not being equal to 0. You can say all reals except y equal to 0. Or you could say the same intervals as before. But this time they're talking about y values instead of x values. Okay? All right, look at your function. If you were on this function from left to right, you would be on one curve. It would be like Super Mario Brothers style. You'd like be on one curve, you would disappear, you'd reappear on the other curve. All of a sudden, nobody knows what happened in between. Okay, so that's what would happen as you're moving across this graph. All right, so I'd be here. I'd be going like this as I moved from left to right. I would disappear, eventually reappear. Okay, that's what would happen. The whole time that that's happening while I'm on the function, am I increasing or am I decreasing? So first branch, I'm on it and I am decreasing, okay? Disappear, reappear, and I am decreasing. The whole time, I know it's weird because you end up back up there, but the whole time, if you are moving from left to right along this function, you are decreasing. So the entire function is decreasing, which means for increasing intervals, there's none. And for decreasing intervals, it's the entire domain written in interval notation, which would be the same as this right here. So from negative infinity to 0, nobody knows what's happening at 0, and then beyond that. Okay? We can't include the 0 because it wasn't part of the domain. You're not doing anything there. Okay? Is the function one-to-one? So it's a function. It passes the vertical line test. Does it also pass the horizontal line test? Yes. The ends look like a horizontal line at 0, but are they actually a horizontal line at 0? No. Okay, so that means it is one-to-one. The rate of change, we just say like varies. What? Oh, sorry. No. Okay. The answer, or yes. I don't know why I'm saying. Thank you guys. I'm like, why are you guys looking at me weird? The axis of symmetry is not applicable. Okay, minimum and maximum values. Does the graph have a minimum value? Like a bottom where you say that is the absolute bottom, that's the lowest y value this graph hits? No. Does it have a maximum value? No. So both of those are none. And then we've ignored asymptotes this whole time, like we don't even know what they are, and now you finally met a function where it's worthy of filling in some information about asymptotes. Our horizontal asymptote here is at y equals 0, and the vertical one is at x equals 0. Remember, asymptotes here are equations of lines. Vertical lines have equations of x equals a number, and horizontal lines have equations of y equals that value, okay? All right, so we're gonna do one more. We're gonna do the graph like we always do the graph. I know it's weird, I know the graph has asymptotes, but we can still do all of the transformations. And if you really understood the investigation well, you could look right here probably and tell me immediately what are our asymptotes. Where's our vertical asymptote gonna be? 8, okay? Why? Because a couple of reasons. Number one, that's what makes the denominator undefined, would be an x value of 8. Reason number two, if I understand transformations, and this is x minus h, my graph is getting shifted to the right 8. So if the parent had an asymptote at 0, and that gets shifted to the right 8, it would now be at 8, okay? What about the horizontal asymptote? 3, okay? Because this is getting shifted vertically up 3, and those are the only changes that are going to affect the asymptotes. Okay, if you don't see that right away, I'll give you another way that you can do that with the chart. Okay, so with our chart, we have our parent function over here, right? Our new function for our transformations, the only thing that's affecting x, we're gonna consider this negative. You could put it where you want. I'm gonna consider it part of the a value because that's a lot easier for me to deal with. So right here, this is x minus h. So the only thing that's happening is an h value of a positive 8. So all the x things are getting shifted to the right 8. And I'm actually going to write it in words too because some of us need a little help with that still. So I have a shift right 8. with my y values, okay, there's no stretching or compressing. Do you guys see why there's no stretching or compressing? This a value didn't change, it's still 1, but it does have a negative that's applied to it, so the y values are going to be flipped, okay? So there's a reflection, and remember when we change the sign of the y values and flip the y coordinate, we actually reflect over the x-axis. Okay. And then outside the function, we have this plus 3. That's our k value. So y's are also getting shifted up 3. So if I make the chart, I go back to what we had before. I'm going to take every value in the x column and I'm going to rewrite it right here, but I'm going to shift it over 8 by literally adding 8 to what the x coordinate was before. So -2 plus 8, -1 plus 8, 0 plus 8, 1 plus 8, 2 plus 8. And if you struggled with your asymptotes, you didn't understand them, if you kind of lumped them in with your chart a little bit, right here, x equals 0, if you took that x value of 0 and did this transformation to it, you would get 0 plus 8, which would be at 8, and that's yet another way you could figure out where your vertical asymptote is if you weren't clear with like the shifting or the undefined value. Okay. Now we're going to take all the y values, we're going to change their sign to the opposite and add 3. So -1/2 would become +1/2 plus 3 would be 3.5. Okay. -1 would become +1 plus 3 would give me 4. Undefined values you can't do any calculation with, so it just remains undefined. So see, that's where our vertical asymptote is going to show up also, because you see that it's undefined at that place. 1 as a y value would become -1 plus 3 is +2. And 1/2 would become -1/2 plus 3 is 2.5. And then if I was unsure about my asymptotes, the y value for this asymptote was originally 0. If you adjusted that y value here, the opposite of 0 is still 0, and you add 3, you get 3. So your horizontal asymptote should be adjusted to 3. Okay. If you couldn't already tell the ways that we talked about prior. Oops. So I'm going to put my asymptotes in at 8 and 3, because I think they provide me with really good guidelines for my graph. And then I'm going to plot the points that are on here. So 6, 3.5, 7, 4, 8 is undefined, 9, 2, 10, 2.5. Okay. And again, this might look pretty sloppy, but you should know the shape of the graph. You should know that it's these two branches that use the asymptotes as guidelines. So when I see these 2 points here and I see the asymptotes, I'm basically filling in curves along those asymptotes using these couple of points as a guideline. Okay. Now, the differences that we see. Still has the 2 branches. When we were plotting the points, I could tell they were the same distances away from the asymptotes as our original function. That's because there weren't any stretches or compressions. Okay, so I see the shifting. The shifting makes sense to me. The other thing I see is that normally in the parent function, it's the left branch that's below and the right branch that's above, but this one has the opposite thing happening. Why is that happening? Emily? Good, because there was a reflection. So like if you know the transformations that occur, you should be able to see if your graph makes sense when you're done with it or not, okay? So in this function, if you want to make a note of the hk, you can, but we definitely don't want to write it like a point. Your h was 8 and your k was 3. Okay. Now in this graph, if we go to solve for x-intercepts, we're setting y equal to 0. And so now we have a rational function that we could solve, right? If we want to use the method that we've been using, we've been multiplying by the LCD. There's only one denominator in this whole problem, which is x minus 8. So I'm going to multiply both sides of this equation by x minus 8. Okay. So 0 times x minus 8 would be 0. X minus 8 distributed to this fraction would cancel out the denominator and leave me only with a -1. And then x minus 8 times 3 would actually have to be multiplied together because it doesn't get canceled at all. So I have 3x minus 24, which then becomes 3x minus 25. So I have 25 equals 3x. X is equal to 25 over 3. Okay? Does that make sense? So if you look back at your graph, 25 divided by 3, that would mean that 3 goes into 25 8 times with a little bit left over. Does your x-intercept look like something that's a little bit past 8? It does, okay? And now you know exactly what that value is. So our x-intercept is 25 over 3, 0. And then for our y-intercept, we would plug 0 in for x, okay? So y is already alone. I'm going to plug 0 in for x. That's going to give me -1 over -8 plus 3. Those will be positives, and so basically 3 1/8, okay? So 3 1/8. And again, if you have the graph, compare the information. That makes sense because this is getting really close to the asymptote here at 3. It makes sense that by the time it's crossing the y-axis, it's only like an 1/8 above 3, okay? The domain here, what's the thing that's excluded from our domain in this function? What's the value x can't be? 8, okay? So if we wrote that in intervals, we can be everything up to 8, and we can be everything past 8. Okay? Or you could say x cannot equal 8, or all reals except for 8. All right, what about the range? What value is excluded in the range here? 3. So same idea, everything up until 3 and everything past 3. All right, for intervals, when we look at the graph, increasing, decreasing, or parts of both? Increasing, right? As you move from the left on the first branch, you would be increasing the entire time. Somehow you disappear and you end up on this branch, and then you are increasing the entire time. So the entire domain you can just copy down as the increasing interval because the entire function is increasing. So all of the domain is increasing, and that means no decreasing. They are 1 to 1. We don't have to worry about rate of change or axis of symmetry. Okay. What about minimum and maximum values for these graphs? None, because even if there's a reflection or a stretch or compression, because they have the behavior of those two branches and they are always opposite of each other, we always have no minimum and no maximum value. And then the horizontal asymptote here you guys already determined was at 3, and the vertical asymptote was at 8. Okay. Is this okay with everybody? Okay. So